Welcome, everyone. Thank you for joining this week's CSAE Development Economics webinar. Before I introduce our speaker for today, let me briefly introduce myself and set the ground rules. My name is Lukas Hensel. I was a postdoc at CSAE and I'm now a visiting fellow there, working on all kinds of development related topics. And the seminar today will start right now. Jeremy will speak for 45 minutes. During this time, you may ask clarifying questions using the Q&A function. And we would like to ask you to only ask clarifying questions during the presentation. After the presentation, you'll have around 30 minutes to answer all other kinds of questions. Well, thanks for joining us. And without further ado, I look forward to Jeremy Magruder's presentation on factor market failures and the adoption of irrigation in Rwanda. Jeremy, the floor is yours.
I will do my very best to keep to time. And please don't be afraid to let me know if I fail to do so. I am really excited to give this paper in this seminar series. I only wish I could be there in Oxford, but hopefully I'll be able to sometime soon. So this project is joint work with Maria Jones, Florence Condilis, and John Lozier, all of whom are in the DIME group at the World Bank. We've been working in Rwanda on this project for a few years now. I think our first trip was in 2014, so it's pretty exciting to see this paper be finished or nearly finished at that stage. I like to motivate it with a graph that's, I think, familiar to many of us. One thing we know about the world, and one of the positive things about the world, is that yields, and this picture shows cereal yields, have been rising at a pretty constant rate over the past half century or so. They've been going up by about 2% a year in much of the world. It's true in the United States, it's true in East Asia and the Pacific, it's true in Latin America and the Caribbean. It's been true in South Asia, and the only continent where that hasn't been true is Sub-Saharan Africa, where we do start to see a little bit of yield growth in the last decade or so, but it's been quite a bit slower. The reason I like to highlight that figure is just to highlight that I think we have some ideas for some of the reasons behind this. Clearly, the Green Revolution is an important contributor to these changes in yields. And understanding why some of these technologies haven't spread in Sub-Saharan Africa is quite important. One thing that I think it's important to not lose track of, just zooming in at South Asia and Sub-Saharan Africa, which I think critically had nearly identical yields in 1960, or maybe South Asia was about 10% higher or 20% higher, but massively different yields today, is that another thing that happened during the same time period is that South Asia became irrigated. At the beginning of, back in 1960, agriculture in South Asia was largely rain-fed. Today, about half of it's irrigated. That contrasts with about 3% of land in Sub-Saharan Africa that's irrigated today. And so one of the sort of comments we want to, or contributions we'd like to make in this paper, is to understand what irrigation might do to yields in an African context, where we've had much less evidence than we've had in South Asia. We cite a number here that suggests that yields went up by about 70% due to irrigation. And so some of this, it seems reasonable to strongly suspect that some of the changes in yields that we've observed there have to do to a switch in farming systems as much as to other technologies that have been introduced. So what are we going to do in this paper? What we're going to do in this paper is estimate the returns to irrigation using a plot level spatial discontinuity and access to some new irrigation sites that have been constructed in Rwanda. I'll fix ideas with some pictures in a moment, but for now, I know these are Hillside irrigation systems. The government built them, so none of the beneficiaries paid for them in any way. They provide free water year-round to farmers. What can you do with free water year-round? Well, Rwanda is not the driest place in the world, so it's not necessary for staple cultivation. But it does allow you to produce dry season horticulture in the dry season, which is quite high value. Horticulture is, in this context, is going to be vegetables for sale in Kigali, primarily tomatoes, onions, eggplants, that sort of thing. What we're going to do in this paper is do a spatial regression discontinuity design, and we're going to compare very proximate plots that receive access to this irrigation with plots that are immediately next to them that don't. And what we're going to find is an order of magnitude returns actually quite similar to the Duflo and Pandey number that I quoted earlier in terms of yields from India. We see that irrigation increases to about a 46 to 70% of revenue weighted yields net of expenditure. This is a TOT estimate. These are large returns, we think, particularly given that we'll show you that really all they're doing is allowing you to grow vegetables for 3 months of the year in the dry season. And yet you're seeing cash profits, cash revenues, I guess, go up by 50 to 70%. So this seems like a pretty important technology. I think it makes sense to people that spend time thinking about agriculture that irrigation would be quite important. We're also going to observe that despite this, we're only about 30 or maybe 40% of farmers are going to make really any use of the system whatsoever. And by make use of the system, I mean the water's free, so only that fraction of farmers are going to turn it on. That number, it could be high, could be low, depending on what your priors look like. To us, it was quite low, given that this seems like it should be a potentially transformative technology. On the other hand, it's pretty high compared to other technology adoption studies that we've observed. We can iterate back to this later, but I kind of suspect this might be the short-run ceiling for adoptions of new things. So that said, 30 to 40% is low in an objective sense, and in that specific objective sense is that the system it's not a high enough system to support a tax base that would allow the system to even pay for ongoing operations and maintenance costs. Sustainability is very much in doubt unless many more farmers start taking advantage of this system. And so we want to take seriously two possibilities about why adoption might be far from 100%. One is that returns might be heterogeneous. Maybe this is efficient low adoption. The other is that these farmers may face some constraints in how they make productive decisions, in which case these constraints might prevent some efficient use of the system. What kind of constraints could matter? Well, really any could. It turns out that to grow this high value dry season horticulture, it's an increase in demands for all, it's associated with a large increase in demands for all inputs, most especially household labor. And so if there are frictions in any of these markets, it may constrain your ability to profitably cultivate this high value horticulture. Why might it be inefficient? As I said, farmer constraints might matter. One thing that's kind of exciting about working in this space is we've got a pretty good idea now what happens to smallholder farmers when we randomly generate a little bit of slack in a range of constraints. There are by now quite a few studies that look at providing rural credit at subsidized rates to farmers, quite a few studies that offer various sorts of index insurance products, quite a few studies that try to tweak extension systems to provide information better. There's a resounding result from all of these studies, which is that if you create slack in any one of these constraints, you get some minority of farmers to take up your product. They take your credit product, your insurance product, if it's heavily subsidized enough. They listen to your extension agents. You change outcomes. You manage to induce a minority of those who take your product to spend some additional resources on inputs and expand their technological frontier. And so we know that these constraints all matter. We also know that no one of them is the reason why agricultural productivity isn't growing in sub-Saharan Africa the way it is in the rest of the world. Where we've had less research, I think, up until this paper is on the possibility that some of the reason that production might not reach the frontier may have something to do with frictions in land and labor markets. These are markets where we know there are substantial frictions, even in places like South Asia where these markets are particularly active. It doesn't take a lot of ethnography of sub-Saharan Africa to know that land and labor markets don't operate like the sort of perfect, idealized, optimized market structure that we learn about in Econ 101. There's some suggestion in some of the literature that these inefficiencies may lead to some quantitatively important outcomes, although the other folks who are here, I think, have pointed out that measurement error is also important in some of these studies. So what do we want to do with this? Well, what we want to do is develop a new test for separation failures that are induced by these factor markets and provide evidence that land and labor market frictions in this particular context are generating an efficient adoption of irrigation. And we'll have probably not enough time to point out that we tried to find evidence that of some financial constraints or information constraints mattering as well, and we just objectively failed to do so. It really looks like the constraints that we can see are that land that receives access to irrigation is held by farmers that aren't able to productively use it because labor markets are setting wages inefficiently. So that's what we're going to do in this paper. Without further ado, let me enter into the context and give you some more specifics about how we can make statements along these lines. What should you think about when you're thinking about our farm sample? Agriculture in Rwanda is dominated by smallholders. In our sample, the median land holdings is about 1/3 of a hectare per household. So these are quite small land holdings. It's an interesting place to study land market frictions and labor market frictions because these markets actually work reasonably well in Rwanda. All of the land that we're talking about is formally titled, at least in principle. Maybe not all the farmers have gone down to the district office to actually receive their title, but the titling exists for all of it. There are land rental markets. There are hired labor markets. About 85% of the labor that we observe is going to be household labor on their own farm, but that means, about 1/6 of labor is hired in. So in contrast to some other contexts that we might have worked, this is a place where we might think land and labor markets would work particularly well. As far as farming itself, there's annually 2 rainy seasons and 1 dry. The rainy seasons, in the absence of irrigation, what you would do if you were a farmer is either grow bananas year-round. Bananas are a perennial that takes about 18 months to start producing and then produce for several years throughout the year, or do a rotation of rainy season staples, which are largely maize and beans. There's 2 rainy seasons, so most of the farmers in our sample would have had 1 season of maize production, 1 season of bean production, and then let the land sit fallow in the 3rd shorter dry season. It's worth noting you can't grow maize or beans in the dry season. The dry season is too short to grow maize and beans. So even with water, it's just a non-starter. Or they do the other thing that farmers might do is an intercropping version where you have a few sort of sparse banana trees that you grow maize or beans underneath. What is irrigation going to do in this context? Well, it's going to allow you to use that dry season to grow vegetables. When we make that statement a little bit more precisely, looking at our data, these are from our data, and just splitting cultivation into staples, bananas, and horticulture. What do we see? Well, starting from the bottom 1/3 of this graph, we see that literally all staple cultivation takes place in the rainy season. That's because the dry season is too short for staples. We see that bananas cultivation takes place year-round in both the rainy and dry season. That's because banana trees produce year-round. And we see that horticulture cultivation takes place primarily in the dry season, although a little bit in the rainy season as well. It's going to turn out that when it takes place in the rainy season, and I'll show you this later, the farmers don't actually need the irrigation to grow it. So the decision to not grow vegetables in the rainy season is because farmers prefer to grow staples at that time, not because they can't, absent the irrigation. What do farmers use irrigation for? Well, they literally never use it for staples or banana cultivation, and they use it nearly always when they're producing vegetables, which is going to line up exactly with this fact that they're producing vegetables in the dry season when you couldn't possibly grow vegetables without water. The other thing that I think is worth having in mind is a sense of production functions. So we have our 3 crops here. Of them, bananas require the least in terms of inputs and produce the least in terms of yields. So you can see in this sort of middle column here so the middle column just looks at money input, so fertilizer, pesticides, other things that you might spend money on, as well as hired labor. And then on the right, it's going to include household labor that we value at the going wage rate, which is about 800 francs a day. And so profits is either the difference between the gray bar that doesn't value household labor if household labor is not taken at any value, or the gray bar that does value it at the wage rate if household labor is valued at the wage rate, or something in between these 2 marks if household labor is valued somewhere in between 0 and the wage rate, as a couple of recent papers have suggested, and a long tradition has suggested it might be. The reason I think this is worth pointing out is that the right model you should have in your head for banana cultivation, I think, is essentially that you plant some trees and then sometimes there are bananas and it requires no inputs whatsoever to get those bananas. That's going to turn out to mean that bananas are very low revenue, but very low input intensiveness, and in fact, are going to turn out to be a pretty profitable form of agriculture. Staples produce more in the way of revenue. They require more in the way of input expenditures than bananas. They require a lot more in the way of household labor than bananas. It's going to turn out, and sort of the first point that sort of jumps off the page here is that if you were to value household labor at the going wage rate, it's not at all clear that anyone should be growing staples. Staple production looks not profitable at all. It's certainly less profitable than banana production. And this is going to turn out, the fact that farmers grow staples in Rwanda is going to be our first signal that probably it's the case that household labor is not valued at the going wage rate. This is not unusual about our data, by the way. This is a pretty standard finding in agricultural surveys in developing countries. Finally, horticulture is an order of magnitude, well, it's about double, produces about double the revenue of staple production. It's much more profit, it's much more revenue, it generates much more revenue. It requires much more in the way of cash inputs, and also much more in the way of household labor than either staple or banana production. And so it's going to turn out to be the case that just how profitable horticulture is, whether it's clearly the dominant, clearly the most profitable thing you could grow, is going to depend really sharply on how this huge amount of household labor gets valued. If it gets valued at the going wage rate, it looks less profitable than these bananas because it takes a lot of work, and bananas do not. If it's valued at, if it's not valued at all, it's going to look just massively more profitable than anything else you could do. Good. So that's the high-level overview of farming in Rwanda. Let me take you to our site. This is a picture from one of our 3 irrigation sites. It's Hillside Irrigation. The hills are quite steep. They've all been terraced recently. Which is, it's sort of necessary. You could think of that even as part of the irrigation infrastructure if you like to. You can't really pour water onto a steep hill if it's not terraced. The way that these systems all work is that there's a main canal that connects to a distant water source. It's usually 1 or 2 kilometers away, and it's either a river or a lake that's been dammed. And then from that water source, there's a canal that goes at a prescribed gradient along the hillside. It's right here, or I hope you can see my cursor at this sort of kind of tall bench of the hill. At that bench, there's this canal coming down along that's drawing the water from the water source. And then along the hillside, every 200 meters, there's going to be a secondary pipe that goes down the hill. And what that secondary pipe is going to do is you open a valve on the main canal, secondary pipe fills with water, and then on every 3rd terrace, there's going to be a little inlet that you can hook a hose up to. The intention of the system was that you would dig furrows along your terrace and then use that hose to fill those furrows with water. And practice digging furrows is a lot of work. So what people do is carry the hose along their terrace and water by hand. That also is a lot of work, but I guess less work than digging terraces, digging furrows. Noreen asks, who provides the household labor? Is it women? I believe it's both women and men in this context. I'm not sure that our data allows us to say exactly who it is, although our next data set will, and I'm really eager to chat with you about ideas on how to use that. Yeah. Okay, good. Okay, so this is our context. You can see already our identification in this picture. Above the canal here, all of the benches are growing maize and bananas, and below the canal, they are not. In fact, you can sort of see here, this is some, I don't know which sort of vegetables, but sort of in very small form right here. And so what we're going to do is just zoom in at the canal and compare these plots right above the main canal that are growing maize to these plots right below the main canal, which are not, and are sometimes growing vegetables and sometimes not. And so that's our identification strategy. How are we going to do that? Well, we did, this was kind of a really fun exercise for us. we wanted to do a sampling procedure to try to be able to do a regression discontinuity, which meant we knew we had to sample very densely near the discontinuity itself. So what we did is we randomly dropped GPS coordinates within 50 meters of the command boundary, sent enumerators to identify the household who cultivated each of those plots. We're going to call a plot that's associated with one of these pins that we dropped our sample plots. And they're going to form our main benchmark for analysis. We then interview that person and collected 4 years of data on, it's behind my, look at my pictures, but it'll be about 1,700 farmers from 3 irrigation sites. Our baseline is going to go back to the 2014 dry season. We'll show you in a second, it's not a perfect baseline in the sense that a few farmers seem to be accessing using some irrigation at that point, but it's close to. It was only a part of one of the sites that was online at that point. What we're then going to do is maintain a panel of both that sampled plot and the farmer's other most important plot, which we'll call the MIP. Our data is going to have plot maps. We're going to have agricultural inputs and production by season over 4 years, and track plots if they are exchanged to a different owner. One nice thing about working in the Rwandan context is that we were able to do this with extraordinarily low attrition at the household level, less than 5% after 4 years. As I mentioned, we had to sample very closely to the discontinuity. This is our sample in one of the sites. What you can see is that the yellow frames are plots within our site that are in our sample. The orange are plots that are not irrigated that are within our sample. And what you can see is that we're covering nearly all of the plots in and immediately around these irrigation sites. So one of the things I think is kind of cool about these data that we collected is that we aren't going to be well powered on market level outcomes because there aren't very many markets serving these sites, but we know almost everything that happens in and around each of the sites that we're working. And I think that's pretty rare for at least recent data collections. Okay. What are we then going to do? Well, we're going to do a few different ways. We're going to implement spatial regression discontinuity a few different ways. So we're going to zoom in at the canal, as we do here, and compare plots in our sample that are outside of the command area to those just inside. I'm going to show you a lot of figures that look like this one on the right, including this one in a few slides. What's going to happen on the y-axis is going to be our outcome variable. In this case, it's whether the plot is irrigated or not. On our x, Julian, I see your hand. I'll get you in just a second. On our x-axis, it's going to be the meters to the boundary of the command area. So 0 will be the canal. Going to the right, you're going down the hill. Going to the left, you're going up the hill. And we're going to see how outcomes change right at the canal. I want to draw attention to the fact that because our sample is so dense, we're using extraordinarily close comparisons. These are plots that are literally within a few meters of each other. Julian, did you have a question?
Yeah, just a quick one. Given your sampling strategy, should we think of this as like the highest possible return to education? Because I'm guessing the plots that are so close to the border are going to get most of the water, and as you go down, some of the water is going to be lost and they will have less access to it. Or am I completely wrong?
It's a good question. That was actually our guess going into it, and it turns out to be the opposite. The way that these plots work, it's the right way to show this. So if you picture picture the site, so the way that the system works is that there are these secondary pipes going down the hillside, and so those fill up with water, and then you open your inlet to let the water out. And so it turns out that the pressure at your particular inlet is determined by the volume of water over the inlet that you open up. And so at the bottom of the hill, they have the most pressure, and at the top of the hill, they have the least because there's just not as much volume of water. So to some extent, we think that the right at the boundary itself, this is where the site works the least well. Now, it's also the case that it's closer to the top of the hill, and so if there are any advantages of being further up the hill, we'll see it come out of there. What we do see in practice, you can see it in this chart, and you'll see it in all of them, is that as you go down the hill, people start irrigating more. They start growing more horticulture and things like that, which is a signal to us that the farmers think down the hill is a better place to use the system. But it could also be that to some extent, this is why you do a regression discontinuity instead of just an above and below comparison. The land down at the bottom of the hill could be marshy, or it could be better for horticulture for other reasons too. So it's harder for us to say.
Thanks.
Sure. Yeah, that's a great question though. It was exactly our guess, and we were surprised to learn that in fact we were getting a lower bound. So what are we going to do? Well, we're going to start out with just a really simple regression discontinuity estimator. We'll look at outcomes for plot outcomes in what we'll call plot 1, the sample plot for farmer I and season and household I and site S at the time T. It's a function of whether that's in the command area. Being in the command area is an indicator for meaning below the canal. It's whether you plot irrigation. The distance to the canal, times being in the command area, covariate that I'll get to in a moment, site by season and site by season fixed effects equals an error term. How are we going to implement this? Well, the first thing we'll do was to restrict the bandwidth. So we'll just restrict our sample to plots that are within 50 meters of the canal. Again, we're pretty excited about just how local we can make these comparisons, and so we can do that without massively losing sample size. The second is that so that work goes through fine. The one sort of in general, sample characteristics look balanced, and in the interest of time, I think I won't show you that table, but I can later if anyone's interested. There's one exception, which is plot size. The plots below the canal are bigger on average than the plots above the canal. We think that's because the canal is kind of near the top of the hill, and plots tend to stretch up or down the hill, so they sort of are, the canal itself is censoring plots, so they sort of have to mechanically be larger below the canal than they are above the canal. So what we're going to do in this is control for log area. It doesn't make much of a difference in any of our estimates, and if anything, it should make us conservative because smaller plots are higher productivity in these data, so and more likely to grow horticulture and things like that. But that's what we observe. The other possibility that we want to take seriously is there might be meaningful unobserved productivity differences along the canal. So just going back to our sort of site map, when you do a simple border discontinuity, you're implicitly comparing all of the sites that are near the canal in one part of the site with all the sites that are away from the canal in across the site. And the logic that this plot right next to this plot should be similar seems pretty sound. It's less clear that this plot should be really similar to this plot, these plots over here. And if you have a case like we do here, where there's differential density of plots on either side of the canal in some parts of the site, that could lead to some bad outcomes. So what we're going to do to solve that are spatial fixed effects. And so implicitly what we're going to do is demean all of our y and x variables by the average of the 5 closest plots to that particular plot. And what that's going to do is only compare a plot to its 5 closest neighbors. Because our sample is so dense, those 5 closest neighbors are all super close. 50% have all of them within 50 meters, 87% within 100 meters. So we're going to be able to get a good comparison of pool of plots that are literally right next to each of the plots in our data to do that comparison. What do we observe? Well, we observe that over time, adoption of irrigation grows, and it grows sharply once the system becomes fully online here in the part where we don't have data. Before the system's fully online, we see about these pink blips show you that about 5% of 5% or 7% of farmers are irrigating in both dry and rainy seasons before the system becomes online in the site, versus about 1% outside of the site. That number jumps in the dry seasons once the site is fully online to about 25 or 30% for our treatment effect estimates, in comparison to a much smaller change outside of the site, which might be due to some measurement error. Or it could be due to someone manually taking buckets from the canal, although you saw how steep those hills are, that would be an awful lot of work. And so what does this mean? Well, so we do see a big sharp change in how people are using the system. People are starting to cultivate with irrigation. It's far from 100%, and this is the graph that when we've been engaging with our partners in the government, they're to some extent most concerned about. It's also not the case that this is a short-run blip. By year 4, cultivation of the system, cultivation in the dry season is no higher than it was in year 2 or 3. The other thing to notice is that cultivation never really changes in the rainy season. You see a few percentage points more irrigating in the rainy seasons throughout our sample in the command area. And so what we're going to do is for now, just focus all the analysis I show you on the dry season results, because that's when people are irrigating. We have in the appendix the rainy season results. We don't observe any meaningful changes in the rainy season. The other thing is that since our baseline isn't a perfect baseline, there are a few differences. What we're going to do is just do the pooled RD estimator using the subsequent surveys, the midlines and endline, for our main estimates. Okay, so what do we see? What happens when you give people access to water? Well, they don't start cultivating more in the dry season. That was a big surprise to us, and another graph that is somewhat alarming to our partners in the government. We see that, so this is heading down the hill, absolutely no change in the likelihood of cultivating in the dry season. It's stuck at about 40%. But that doesn't mean that there aren't big changes in farming practices. What happens is that heading down the hill, we see that farmers are much more likely to cultivate using irrigation water in the dry season, jumping from about, I think about 8% here to about 25% here. And then again, increasing as you get further down the hill, and then the system presumably works better. If they aren't changing their cultivation, what are they doing? Well, they're stopping growing bananas and they're starting to grow horticulture. And so there's an almost one-for-one change in which farmers stop growing bananas right at the canal, and they go from a 25% cultivation down to about 10, and they start growing horticulture, start growing these vegetables, and grow from about 7% up to about 25%. And so these numbers look very similar, and that's why overall cultivation doesn't change. Above the canal, people are growing bananas. Below the canal, they're growing vegetables in the dry season. What does growing vegetables versus bananas mean? Well, it means you need to use a great deal more labor. So this is person days per hectare of household labor. That jumps from about 60 to about 130 right at the canal. Remember that only about 18 additional percentage points or something of farmers are actually irrigating. And so when we do the treatment on the treated estimator, we see that irrigation is associated, growing horticulture versus bananas is associated with about 400 person days per hectare of additional household labor. So that's a huge amount. Keep in mind that these households only have about a third of a hectare. So that's about 100 days of labor per hectare, or in other words, working every day in the dry, one person working every day in the dry season, which is about 3 months long. They also spend quite a bit more money. They spend about 50,000 francs of additional inputs per hectare once you do the treatment on the treated estimate. 50,000 francs, it's about 800 francs to $1, so it's about $60. That said, those input expenditures are associated with huge increases in yields. So we see that the yields jump by quite a bit. The ITT estimate is 80,000 to 130,000, so about 50,000, which then again you multiply by 6 or something to get the TOT. So that's something like 300 to 400,000 francs increase in yields, which is about 50 to 70% of annual production. Those yields, for people interested in commercialization, those yields are 1-for-1 associated with increases in sales. People sell their vegetables, or 0.8-for-1 associated with increases in sales. And so this is really, this irrigation infrastructure is really providing these farmers a transition out of subsistence agriculture and into commercial agriculture. And associated with that, there are big changes in profits, but they're going to depend critically on how we value this huge amount of household labor. So if we think that the right way to think about household labor is that it's free, then they're associated with an enormous impact in household on profits that's essentially identical to the impact on yields. And that's because compared to the yields, input expenditures are just trivial in magnitude. On the other hand, if we value it at the going wage rate of 800 francs a day, there's no change in profits or no statistical one, and not much one-in-point estimates at the boundary. And that's because so much additional labor is being used to grow these vegetables. And so what we think about the profitability of irrigation is going to depend critically on how valuable we think household labor is. There are 3 types of GE spillover effects that we think about in this context. One is that there's a big increase in labor demand. This should push wages up. There's a big increase in horticulture supply. This should push prices down. We don't see really any evidence that this actually happened in our context, which is consistent with these wages being set, with labor markets having frictions in how these wages are set. What does this mean in practice? So it means that our impacts of irrigation estimates that we have are conditional on these prices, that any changes in prices that we don't accurately measure very effectively. If trade was frictionless and wages didn't go up and prices didn't go down, then presumably the effects would be larger still. There's a second type that we worried about a bit, which is that bananas are a year-round crop or multiple year crop. So that should have an effect on both the dry and the rainy season cultivation of bananas. If you're not growing bananas in the dry season, you're also not growing them in the rainy season. We don't really find much evidence that anything on labor, on any of our outcome measures change in the rainy seasons. So the substitution of horticulture plus staples is doing something similar to the usually intercrop bananas plus staples in the rainy seasons in our data. What we do want to spend more time talking about are spillovers within the household and across plots. What we saw is that labor and input demands increase a lot on the sample plot. And so households may well be substituting away from their other plots. So if one of your plots suddenly needs a lot more labor and you have to pull that labor from somewhere, one place you might take it from is your other plots. If you're riding a constraint, if you're using all of the labor you can or spending all the money on inputs that you can, this is likely first order. You literally have to one-for-one substitute any change in inputs going to your sample plot by pulling it off of another plot. And so what we want to do next is just model these quickly and quantify implications for our estimates. Now, obviously, I don't have time to go through a full model, and I think I can do this one with cartoons, so I'm going to try to do it with cartoons. What do we see? So what do we want our model to capture? Well, we want to capture the fact that there are large apparent benefits, but most farmers choose not to irrigate. Our results suggest that heterogeneity in shadowage could potentially explain this. Alternatively, there could be heterogeneity in returns to irrigation across the plots, in which case this would be inefficient. Maybe it's just only 30% of plots have the right sort of land for vegetable cultivation. And so what we're going to do is propose a test for efficient adoption based on separability of production about plots. And the intuition is that we know about 2 plots per farmer, both the sample plot that I've shown you data from and the most important plot. When your sample plot gets access to irrigation, there's going to be a large increase in input demands. And as I said, if you're facing constraints, you have to respond to those inputs demand by pulling them off of some other use of those, which is presumably your other plots. Noreen had a question about GE effects being different over the years. Not that we can measure, but we don't have great price data. As I said, the challenge with our data set is that it's really deep within the sites, but really thin on markets. And so we don't have the sort of lots of observations of markets that you want to really answer that question effectively. Okay, good. So what is our model? Well, so our model basically says that, okay, I don't know how to go back on this. This will do it. So if you buy our identification so far, what we've basically said is that it's as good as random. So let's think about 2 different households. And so if you buy our identification so far, it's basically as good as random, whether you were thinking about household 1, who's had a plot just above the canal, or household 2 who had a plot just below the canal. The fact that the canal happened to pass here make these 2 households similar. Since they're similar, they should be similar in the characteristics of their other plots as well. And so that means that if household 1 has another plot below the canal, then household 2 is likely to have another plot below the canal as well. And they should be similar in their distribution there. So let's focus on that example. The idea of our model is that if it's efficient to grow tomatoes in the irrigation site, then household 1 and household 2 should both be growing tomatoes in the irrigation site in all 3 of these plots. And the fact that household 1's other plot happened to fall above the canal, household 2's other plot happened to fall, sample plot happened to fall below the canal, shouldn't have any implications on what they're doing on these most important plots, which are otherwise similar because the difference between these 2 households is as good as random. On the other hand, if household 2 faces some constraints, if, for example, they only have 4 workers they can use to farm land, then they're going to have to reallocate those 4 workers in some way on these 2 plots. So household 1 can still apply all 4 workers to their most important plot and grow lots of tomatoes on it. Household 2 is going to have to either pick one of these 2 plots to grow tomatoes on, or grow tomatoes sparsely on the 2 plots, as they only have 4 workers available. And so that's essentially our entire model. It's a pretty simple way to test separation failures. In the paper, we do it formally, building on Singh, Squire, and Strauss 86 and Benjamin 92. And what we can show sort of formally is that depending on the substitution and complementarity patterns, if any constraints bind, whether they're based on risk, whether it's based on credit or based on labor, what farmers should be doing is pulling resources off of the most important plots in response to the irrigation shock. And so if we see any of these inputs going down on the most important plots, that's going to tell us that there are land market frictions, because otherwise someone that isn't constrained should swoop in and rent in that land. But it won't tell us whether there's land market frictions and also risk insurance frictions, whether there's also credit frictions, whether there's also labor frictions. And so what we sort of work out in the model is one kind of, I think, generic result, which we find quite interesting, which is that, you know, credit and risk constraints are really financial constraints. And so under pretty normal and reasonable assumptions, what we should anticipate with credit and risk with financial constraints is that richer households should be less impacted, right? And so what we should be able to see is that poorer households pull more off of their other plots, richer households pull less off of their other plots in response to this shock. And bigger households are just richer households, so bigger households should also pull less off of their other plots. On the other hand,
just let you know, you have about 5 minutes left.
Perfect. I will get there as well as I can. Thank you, Lucas. On the other hand, if the constraint is labor, then there's a big difference, which is that if the constraint is labor, then what matters is how you trade off leisure for consumption. And presumably richer households are less willing to give up a lot of leisure for a little consumption than poorer households are. And so they're going to be, in particular, the households that pull the most off of their other plots, whereas bigger households who have plenty of labor will pull less off of their other plots. So that's going to be basically our test. So all we're going to do is do the exact same specification as before. All we're going to do is switch out whether the left-hand side variable is the sample plot or the most important plot, but then keep on the right-hand side the sample plot identification. So we'll see that the sample plot gets access to irrigation. What happens to outcomes on the most important plot? Okay. 5 minutes will get me through these at least, so that's good. So what we're going to see is a remarkable symmetry. So the black lines on these figures are the sample plot, the pink are the most important plot. I showed you already when the sample plot gets access to irrigation, it becomes irrigated. With the pink, we see when the sample plot gets access to irrigation, the most important plot becomes less likely to be irrigated, and that estimate becomes statistically precise when you control for whether the most important plot, when you look only at the most important plots that are also in the command area, which are those that could be irrigated. Similarly, we saw that when the sample plot gets access to irrigation, it becomes less likely to cultivate bananas. When the sample plot gets access to irrigation, the most important plot becomes more likely to cultivate bananas. The sample plot gets access to irrigation, it became more likely to cultivate horticulture. When the sample plot gets access to irrigation, the most important plot becomes less likely to cultivate horticulture. And again, those results become statistically precise if you look at only the most important plots that could cultivate horticulture, which is the ones in the irrigation system. Finally, when the sample plot, we saw these big changes in labor demands. When the sample plot gets access to irrigation, it uses a lot more labor. The most important plot uses a lot less. Sample plot uses a lot more inputs. The most important plot gets a lot less. And so we see sort of a one-for-one change, and we sort of can't rule out the order of magnitude that all of the change in inputs going to the sample plot are being pulled off of these most important plots. We see a one-for-one change that in order to irrigate these sample plots, farmers have to pull resources off of their most important plots at a high rate. That tells us that this isn't efficient. That tells us that there's a market friction that's binding somewhere. It doesn't tell us exactly which friction it is. As I sort of mentioned, the key dimension is going to be, do richer households respond more or less? And if it's something about money, richer households should be less subject to that friction. They should respond more. If it's something about labor, they should be more subject to that restriction. And if it's money, they should respond less to the sample plot shock. If it's other, they should respond more. And in fact, just previewing what we observe, these are going to be just our coefficient estimates. I'll just do one or two of these because the pattern is all the same. This is sort of the main estimates that show that households are less likely to irrigate their most important plot when the sample plot gets access to irrigation. These purple ones are what happens if your household gets bigger. If your household adds 2 members, you're less responsive than you were if your household had 2 fewer. If your household gets 1 standard deviation richer, you're even more responsive than you are if your household's poorer. So richer households are less likely to irrigate their most important plots. Bigger households are more likely to when the sample plot gets irrigation. Bigger households are more likely to grow vegetables. Richer households are less likely to on their most important plot. Bigger households use more labor per hectare. Richer households use less on their most important plot, and so on. So I'm out of time, just about. So let me just summarize what we did, and I'll mention why we're pretty confident that this is the right conclusion. So what we see is that there's a big change in potential profits associated with irrigation. We see only about 30% of farmers really take advantage of this. We know that this is inefficient because we see the farmers that do take advantage of it pulling their resources off of other plots. And that's inconsistent with separability of production across plots. And the fact that richer farmers are much more pull even more off their other plots than poorer farmers do is a pretty big red flag that this has nothing to do with money. And instead, the fact that big households respond much less than other households do is a pretty good red flag that this is something about the inability to sell labor at the market wage rate. We did do one other experiment, and then I'll wrap up, where we actually provided people with some inputs just to be sure that this wasn't a lack of ability to access inputs in some way. And we see that farmers take our inputs and they one for one stop buying them on the market when we give them to them, which is a pretty good signal to us that this has nothing to do with the ability to access inputs to grow vegetables or concerns about basis risk. And so just to wrap up then, where do we get with this? We think these factor market frictions are really important. We think land market frictions really matter. We think labor market frictions really matter. And in this case, which is a really good case for technology adoption, this is a super productive technology that reduces risk. We see that these frictions prevent a lot of farmers from taking advantage of it. And so that is it. So thank you very much for listening. This has been a lot of fun. I'm eager to take questions.
Thank you very much, Jeremy. I don't see any questions yet. Let me see.
Do you want to curate, or should I just answer hands that go up, or what's the right?
Yeah, no, let's start with Victor. I can kind of just call people.
Perfect.
Thanks a lot for the nice presentation. Just two quick questions. One on, in this context, can you say something about the other alternative option that farmers have? Is it possible for them to do some other activities than farming? And is it also potentially one explanation why they don't adopt irrigation, because they can do something else, and so the outside option is better outside agriculture? And also maybe on the, I'm not at all expert in irrigation, but maybe you know this answer. Do you know if in other contexts, and in particular in Asia, since you showed this graph in the introduction about the adoption of irrigation in Asia, whether the adoption at the farmer level is at the same level, at 30%, or is it higher?
Yes. So I think the challenge in doing something other than doing something off farm is primarily driven by the fact that the dry season is short. So if you were to exit farming altogether, you could have a small business. In practice, not very, I don't remember the exact fraction, but that's a pretty small minority of our sample that does that. If you aren't doing that and you're primarily engaged in farming, then that's going to occupy most of your time during the 2 rainy seasons. And so then the question is, what can you do productively during these 3 months of the year when it doesn't rain? And I think the answer is that it's just too difficult to start up and shut down a business in a time period when people have a lot of leisure time and not much else to do. So people don't do that to a large extent. It is the time of year when there are a lot of festivals and holidays and marriages and things like that. So I think there are very good leisure options during this time period that I think probably does consume a lot of people's time. As far as adoption rates, yeah, they're much higher in South Asia, but they took some time to get there. And so, a lot of these systems in South Asia were built in the 50s. And so, we have to sort of rely on historical data. And there are some qualitative reports of, how adoption didn't happen until specific fundamentals were met. And so I think, one possibility is that if we were to come back to this site in another 10 years, and we do have ongoing work around these sites, that we're sort of monitoring them, we'd see something a little bit different. And now it's not clear whether what we'll see will be better or worse, because at the same time that you're waiting for these dynamics to sort of switch into equilibrium, the system is starting to fail a little bit. In fact, even right at the end of our data, we had a big meeting with the project engineers and the government, and the engineers insisted that nothing could possibly go wrong, and they weren't worried about the fact that nobody was collecting taxes on these sites or anything, because these are all gravity fed. There are no motors to replace or anything. And then the next week there were massive rains and sort of washed out part of one of the sites that they've been fixing since. And so I do think there are big sustainability issues that are potentially quite important. Yeah.
Thank you. Carol is next.
Hi, Jeremy. So I was wondering about those plots up the hill, which if I understood correctly, have no access to irrigation. So I guess like your motivating question was why do these plots not have access to irrigation? So in this context, who would be responsible for making these investments? I don't know, connecting those fields to these irrigation schemes.
Well, up the hill they can't really. I mean, so down the hill there's so go back to the picture. The trouble with full screen. The hills are quite steep, and so the canal is right here, right? And so to get water up the hill, you would have to either just hand carry it by buckets. I guess it's hard to get a sense of scale. This bench is something like 8 or 10 feet tall, so you'd have to get a bucket up this 8 or 10 foot bench to get to this plot up the hill, and then keep going up a steep hill. They aren't carrying irrigation by bucket is not a very efficient way to irrigate, or to set up some sort of pumping system to pump water up from the canal. We don't have many reports of people doing that. Now that might be have something to do with the Rwandan context. It's not clear that would have been perceived as taking water from the system that you weren't that wasn't allotted to you or something like that. But maybe not. I don't really know. The reason that basically these plots were designated to not be irrigated, and these was that water has to flow at a particular rate, or else there's too much water pressure that builds up in the system, or the water pools and doesn't flow at enough of a rate. And so, effectively what it is that wherever the river is, that's a kilometer away, this is 2% grade away from that, and that was how the engineer sort of drew the pictures, and so that's where it ended up. We're working now at verifying exactly how close to the underlying engineering drawings of the system went, but our sense is the answer is very, very close. The one counterexample we did observe, one of the times when we visited a site, somebody had dammed the canal to create a pooling area that they could then create additional water pressure to irrigate near the top of both the irrigated part and just above it. But I think that was probably the exception rather than the rule.
I see. Thanks. And just shortly also, so you went by comparing these similar plots, but I was also wondering whether there could be, some point in comparing, household land holding. So I'm thinking maybe there's some room for, different type of optimal crop mixes at the household level. Maybe, if some product markets are not functioning perfectly, or maybe they want to insure against, crop failures, which may be heterogeneous between different types of crops. Maybe they want to diversify. I don't know. Does it somehow enter the picture here?
Yeah, it does. And so certainly that's something that we've been a bit concerned about. We're discussing that as a risk constraint rather than and so the sort of idea, the point of our model to some extent was that, if diversification incentives are larger for those who are more exposed to risk, which under most assumptions on preferences would be the poorer, we should expect to see the poorer face a larger diversification incentive than the rich. So in practice, we should see the poorer more likely to allocate their second lots of bananas, while the richer being less likely to do so. And in fact, we see the opposite, which is just really inconsistent with that being a diversification motive. Yeah, but surely that exists to some extent. I mean, the real thing sort of going on is that bananas are also a commercial crop, and so if you really want to stay out of the risk business, then you want to invest much more in staple production. In which case, you might as well grow the horticulture in the dry season too, rather than allocating some of your lands to bananas, which are going to be sold commercially.
All right. Thank you.
Thank you very much, Jeremy. Kate has a question.
Yeah, so two things. I think I was also thinking a little bit about the risk thing, and I agree with the explanation you gave about the richer versus poorer households. I wondered maybe one other thing could be looking at households that were in some other way insulated from risk. So like if they were getting remittances or they had a non-farm enterprise to begin with, so that they faced less need to do the diversification. But I think that it was a useful story. I guess the bigger picture question I had was like, what is it about the Rwandan context that these particular frictions bind? Because it doesn't seem, you know, I worked a lot in an area in Ethiopia that had similar kind of vegetable farming and irrigation. And when they had labor supply shortages, they got the kids to do some of the vegetable farming. And there was quite a lot of kind of sharecropping or rental. And so I was just wondering what you think it is about the context that those sorts of informal institutions don't seem to be arising here. And what does that mean for the sort of external validity of what you're finding?
That's a great question. Thanks, Kate. So let me first, the remittances are a good idea. We haven't looked at that. With non-farm enterprise, I think we're not, it's not so clear to us that could push on both the labor and the risk side of things, but it might also be useful to look at. So what is it about the context? So I don't think it's so special. If anything, I would have anticipated there being fewer frictions here than there are elsewhere, because this land is actually titled, for example, because there are land sales, land rental markets. We do see rentals increase in response to irrigation. That is a lever that's being accessed here that I think would be unlikely to be accessed in places where land isn't titled. There is a hired labor market. There isn't in all of Africa, you know, and so in some cases it could be better or worse. One thing that I think is true is that might be special about the context is that credit risk and credit and information in particular is probably better here than it is in a lot of places that are much poorer. And so maybe these frictions are allowed to bind because credit and information are sort of sorted out. And in other places that would be harder to do. Yeah, as far as children, you know, it's true that there's compulsory school, primary and secondary schooling in Rwanda, and so that might push a little bit against your ability to use kids to fill some of the labor gap that you have, in a way that there wouldn't, where the schooling wasn't compulsory. Yeah. I don't know that I have I mean, so anecdotally, I think this is from talking to people that work in a lot of other places on labor markets. I think this is not unique, but it may not be true everywhere. I think it's the case that on-farm labor is something that it happens in our data, but that people really strongly prefer to not do, to work on somebody else's farm. And in fact, we're working on a follow-up project where we can see already that when on-farm labor happens, it happens to a dramatic frequency only among people that are very close, that know each other very well in the network, which is a sign that this market is not very well integrated. And I think, you know, it's very plausible that one of the things that one of the reasons for the on-farm labor that we do observe is something more like risk sharing or altruism than it is an actual labor contract. And so I don't think that's specific to Rwanda, but it may not be true everywhere, and that might be sort of place our results in context. It is true, you know. Something I think is important about Africa in general is that people have relatively homogeneous land holdings in our data, and that wouldn't be true in South Asia, for example. And I think that's why you get one of the reasons you get very different labor market, rural labor markets.
Thanks a lot, Jeremy. We still have a few questions, but we are out of time. So I'll use this opportunity to, well, thank you again for presenting this very interesting paper to us today. And look forward to seeing the follow-up projects as well. Before I let you all go, let me briefly remind you about our next week's seminar on June 2nd, again starting at 4 p.m. UK time. We'll have Ian Kondo presenting on borrowing in the shadow of China. So I look forward to seeing many of you there.